So section 2.1, a preview of calculus. Two goals we're going to study, which is how to find the tangent line to the curve, the point, and find the area. For the first goal, how to find the tangent line to the curve at the point P. Let's say here's our tangent line at the point P, and its tangent, like touch the curve at this point. We need to find this line. And for this line, the only point we know is the point P. So in this case, we're gonna assume that there is another point on the curve. This point is called Q. Now, we're gonna get a new line, because to graph a new line, we need at least 2 points to graph a line on the curve. So this line is called secant line. So here's our new line on the curve. It's called secant line. So the line PQ is a secant line. Now, our goal again is to find the tangent line. Now we have a new line, it's called a secant line between the point P and Q on these 2 points on the curve. So now, if you look here, as Q approaches to the P on the curve, as Q approaches to the P on the curve, like now, the location of Q is going to be here. Every time when the point Q approaches to the point P, we can get a new secant line. So here is our new secant line. Now, this is the new location for the point Q, because we're saying as Q approach to the point P. That means we keep approaching Q to the point P, but on the curve. We're gonna get a new secant line. So now, here is the new location for the point Q. So we're gonna get a new secant line. Here's our new secant line. Keep going. The new location for the point Q is going to be here. We're gonna get another new secant line. And we notice that every time we get a new secant line, the secant line is approaching to the tangent line. So we start from this location. Then every time when Q approaches to the point P, we're gonna get a new secant line, and then another new secant line, and then another secant line. You see the secant line is approaches to the tangent line. So now this is the first problem. So every time when Q approaches to the P, our tangent line approaches, our secant line approaches to the tangent line. And this is the first problem in this case. That's how we're gonna know how to find the tangent line. And the second problem, first of all, we're gonna start doing some examples, and then we're gonna jump to the second problem. So before we start the first example, as the Q approaches to the P, the secant line approaches to the tangent line, and this is called the limit. And that's what we're gonna cover on section 2.2. So if we look to the first example here, they're telling you, consider the following problem. Find the distance, travel 30 seconds by object traveling at the constant velocity is 22 feet per second. The first thing, they ask you, this problem can be solved using pre-calculus or this problem require calculus to solve? Let's check that. Can we use a pre-calculus to solve that? We already have a formula. It says the velocity, to find the velocity, is the distance divided by time. Now, our goal from the first problem is to find the distance. We need to find the distance. That means our distance is going to be, our distance is the velocity times the time t. To find the distance, our velocity is 22 feet per second. 22 feet per second, that means it's going to be 22 times our distance, our time is 30 seconds. So that means the distance is going to be 3 times 22 is going to be 66. And here is the 0. That means our distance is going to be feet, 660 feet. So the first thing, this is pre-cal. So we don't have to use calculus. We're just going to use the formula. That means this is a pre-cal problem, and the result is going to be 660. So this is the first example. Let's check example 2. Find the distance traveled 15 seconds and the object traveling velocity. So we need to find also the distance. We have the time equal 15, and we have the velocity now, p sub t equal 20 plus 7. No, we have 6 cosine t. So let's check how we're going to solve this problem. So the first thing they ask you, the problem can be solved using a pre-calculus. The problem require calculus to solve. Yes, the problem require calculus to be solved. Why? Because we have a problem here. You have 6 cosine t. And the second part, they ask you if the problem solved using a pre-calculus, solve it. If the problem seems to require calculus, use a graphical numerical approaches or approximation to find the solution. That means we need just approximate solution, because we know this problem we can use calculus. We have to use calculus to find the exact solution. But now we're trying to find approximate solution. So I'm going to use the same formula because I already know the distance equal velocity times t. So what I'm going to try to do, I'm going to say the distance equal the velocity, which is 20 plus 6 cosine t. The whole thing here is the velocity times the time is t. So times t. You can just plug in the time t here. It's going to be fine, 15. Next step, because I have a plus here, I'm going to distribute the time. That means the distance is going to be 20t plus 6t. Be careful, the t is not going to go here. This is the whole thing is a function cosine t. Now I need approximate solution. What I'm going to do, I'm going to plug in the t, because the t equal 15. So it's going to be 20 times 15 plus 6 times 15 cosine 15. What I'm going to do, I'm just going to ignore this part, and I'm going to say the distance 20 times 15 is going to be 0, and here is a 30. So it's going to be 300. This is just approximate solution by using the pre-calculus, and so I have to ignore this part because this part is required calculus. To find the approximate solution using the pre-calculus, I'm going to say, okay, I'm just going to say it's a 300. That's it for this example. Let's go to example 3. Example 3, a bike is riding on path measured by the function hairs. So here's our function. So this is number 3. Our function, it says f of x equal 0.07x. F of x, we can see this graph. Find are measured where x are measured in miles. Find the rate change of evaluation at x equal 4. So x equal 4. So we need to find the rate of change. The rate of change, if you remember that, is the slope. The slope is the same thing, the rate of change. So now if I look to this function, I have to remember I have a formula. It's called y-intercept form, which is y equal mx plus b. And here is the slope. This is the slope always. So if I combine this formula with what I have, f of x is the y, 0.07 is the slope, x, and b is going to be 0. That means f of x equal 0.07x plus 0. That means here is b equals 0. So here is our slope. That means our rate of change, which is the slope, is going to be equal 0.07. What they ask you here. The problem can be solved using pre-calculus. Or the problem requires calculus to be solved. No, the problem can solve by using pre-calculus. And our rate of change is going to be 0.07. So 0.07. That's the only thing for this problem. That's it for number 3. Let's go to the next problem. We're going to do exactly the same thing, but writing on a path measured by the function. Now our function is going to be, this is number 4. Our function is f of x equal 0.05 10x minus x squared. So where x and f of x measured in miles, ask you find the rate of change of evaluation at x equal 2. So at x equal 2. Let's check that. There is already a solution here, but let's see how we're gonna find that. At x equal 2. So the first thing, if you check, here is the line. At this point, here's our, it's a curve, it's not a line. And here's x equal 2. We need to find the rate of change. So that means we need 2 points. The first point, I have x equal 2. So I need the point. So when x equal 2, I need to find the y. That means I'm going to plug in 2 here, which is going to be the y. So f to the 2 is going to be 0.05, and 10 times 2 minus 2 squared is going to be 0.05, and here is going to be 20 minus 4. And then it's going to be 0.05, and 20 minus is going to be times 16. So it's going to be 0.8. That means our point, let's say P equal x is 2 and y is 0.8. Now again, I need to find the rate of change, which is mean the slope. The slope I can't find the slope with 1 point. I need another point. So I'm going to assume that the other point is a q equal xy. Now I have 2 points. I need to find the slope between these 2 points, which is that's the goal. For the second point, y is going to be, because on the curve, any point x, the y is going to be, here is the y. That means here is x, and the y is going to be 0.05 and 10x minus x squared. So that's the point. This is x, and here is the y. Now, x1, y1, x2, y2. I can find the slope. So I'm going to say the slope is going to be y2 minus y1 over x2 minus x1, which is equal y2 minus y1. So I'm going to say, okay, here is x1, y1, x2, y2. The whole thing here is y2. That's mean it's going to be 0.05 10x minus x squared minus y1, which is 0.8 over x2. Here is x2, which is x, minus x1, which is 2. Now, the next step, we just need to simplify until we're going to find the slope. And again, this problem, you can solve it by using the pre-cal. Oh, no, calculus, not the pre-cal. It's a calculus. So now, let's keep going. What I'm going to do here, I'm going to distribute this part. So it's going to be 0.05 times 10 is going to be 0.5x minus 0.05x squared minus 0.8 divided by x minus 2. Let's keep going. Now, this part is the x squared. It's a quadratic equations, x squared, x, and the number by itself. So I'm just going to arrange it. So 0.05x squared plus 0.5x minus 0.8 and everything divided by x minus 2. Next step, what I'm going to do, I'm going to take 0.05 as a common between these 3 terms. Let's take the negative one. So negative 0.05 as a common. The left here is going to be x squared minus, let's say, 10 times, so 10x, because 0.05, negative times negative positive, 0.05 times 10 is going to be 0.5. Plus, negative times negative is going to be positive. It's going to be 16. So plus 16, because negative 0.05 times 16 is going to be 0.8. So that's right. Everything divided by x minus 2. Now I can factor this part. So I'm going to say it's negative 0.05, open 2 parentheses. Everything is over x minus 2. I'm going to put x here, 16, 8 times 2. And if you add 8 plus 2 is going to be 10. So I'm going to put 8, I'm going to put 2, negative, negative. So negative 8x, negative 2x added is going to be negative 10x. So that's right. If you want to just distribute, it's going to be exactly the same quadratic equations here. Now, we're going to cancel these two. So the left, all these steps is to find the slope. So negative 0.05, and here is x minus 8. Now, at x equal 2, if you plug in 2 here, because x approaches to the 2. That means if I plug in 2 here, it's going to be negative 0.05, 2 minus 8. That means our slope is going to be negative 0.05, and here is going to be negative 6. And then it's going to be 0, negative times negative positive, 0.30, which is 0.3. So as x approaches to the 2, our slope approaches to the 0.3. That's why there is a 3 here, 0.3. That's it for this example. Let's check that. Sure is going to be right. Yes, this is using the calculus. And that's it. We're going to learn an easy method when we start going to section 3.1, 3.2, how to find the slope without using just the old formula, but using the calculus. Let's go to the next problem. Before that, let me show you how we're going to use calculus, because now everything here is a pre-calc. I'm going to do the same problem. I'm trying to use one of the calculus rule, and I'm going to show you how to find the slope without doing all these steps. And don't worry about that. We're going to learn how to do that on the next sections. So to use calculus, so here is f of x equal 0.05 10x minus x squared at x equals 2. The first thing, I'm just going to say, okay, it's f of x equal, distribute exactly the same thing what we did. So it's going to be 0.5x minus 0.05x squared. Then I'm going now to use calculus, one of the calculus rule. So which is called the derivative. We're going to learn that. So you don't have to worry about how to use this method. I'm just showing you, which is going to be 0.5. We're going to delete the x minus 2 times this one is going to be 2.1x. That's using calculus. You don't have to worry about this rule. And you will see the difference. How many steps? It's in fact only one step, because here is the pre-cal. I'm distributing the rule and combine the lactam. So at x equal 2, plug in the 2 here. So f prime to the x is going to be 0.5 minus 0.1 times 2, which is going to be equal 0.5 minus 0.2, which is equal 0.3. It's exactly the same solution. We got it on the using pre-cal. So that's the calculus. You don't have to worry about this method. I'm just showing you the difference between using a pre-cal, which is the old methods, and using calculus. Let's go now to the next example. Next example is, which is about the area. Also, the last section, we're going to study the area, how to find the exact area for this graph. This graph is, there's a curve here. If you look to the first graph, A is a triangle. So we can find the area for the triangle. So for the part A, part A, they ask you, consider the part A. Okay, we're going to look here. How much the height? How much the height for this triangle? The height is 5. So we're just going to plug in the height, which is, be careful, the y. The y coordinate at this point is going to be the height. So the height is going to be 5. And the base from 0 to 5. This is the x coordinate. So the base is going to be 5. That's the first 5 units, the height, and the base is 5 units. Compute the area. This, we're just going to use the pre-cal, how to find the area for a triangle. So this is number 5. The area for a triangle is going to be half base times height. That means going to be half. The base is 5. The height is 5. And you don't have to plug in your answer as a decimal. So 5 times 5 is going to be 25. Just plug in as a 25 divided by 2. So you're going to plug in 25 divided by 2. And also, I think they're going to ask you, no, they ask you enter exact decimal, do not approximate. Yeah, so we're going to plug in 25 divided by 2. That's it. This one's going to be right. Before I hit submit, let's check the next one. For the figure B, we need to find the area only for this part. Check that's difference. And that's what we're going to learn on section, I think, 5.2. But now we need to just to find approximate solution. Approximate solution, if you look to this part, the X here, which is the shade part, and until 2. That means 2 units. Be careful, it's not -2 because we need to find the area. There is no length width with negative. So that's mean. How many units I have here? I have 2. So I'm gonna say only to find the area, I'm gonna say, okay, this is for the part B. I'm gonna say the width is equal to. But if you look to the length, because it looks like square, a triangle, you can tell. Because if you look here, it's end here, but this part is also exist because we have a curve on this from the top. So we can say it's a rectangle, we can say it's a square. But what I'm going to do, I'm going to say, okay, my length until here on this side is 3. But the curve is going up until 3.5. So what I'm going to do, I'm going to say, okay, I'm going to take 3.5 as an approximate. So I'm going to say the length is 3.5. So to find the area is going to be length times width. So it's going to be 3.5 times, careful, it's 3.5, 3.5 times 2, and the result is going to be 7. This is approximate solution. And again, we're going to learn how to find the exact area on section 5.2. So in this case, we're just going to plug in here 7. And that's it for this example. Let's submit. Here's submit button. Oh, here. That's it for this example. Let's go to the next example and check for the next example. The next example, they ask you to consider these two graphs, 1 and 2. And if you look to the graph, it's a curve. We need to find the area for this part. You see, under the curve. That's what they ask you to find the area. So what they did, they divide the area to a triangles here. 1, 2, 3, 4. Because here we're gonna find approximate solution. We're not gonna find the exact area. So we're just gonna find an approximate solution. And check here, they divide the same graph to 1, 2, 3, 4, 5, 6, 7, 8, to 8 triangles. So let's check how we're gonna find the solution for these 2 triangles. And then we're gonna answer one of these, choose one of these questions. The first thing, let's check how we're gonna do that. We already know it's a triangle, so the area for each triangle is going to be the height times the width. That's the first information. So for the first triangle, I already know to find the area for each triangle, talking about number 6A. Number 6, the first graph. And let's check the information they give it to us. They're telling you y equal 5 over x, and y start from 0, y start from 0 to 5, and x start from 1 to 5. Okay. We have y equal 5 divided by x. If you look here, the width for each triangle is 1. So here is 1, here is 1, here is 1, and here is 1. But the change is going to be on the length. The length is changed according to this function, y equal 5 over x. So I need to find the y for each triangle at this point, this point, this point, and this point. So what I'm going to do, at x equal 1, which is the first length, again, our length is going to be approximation solution. The area for this is going to be approximation solution. It's not going to be the exact area. So when x equal 1, y is going to be 5 divided by 1 is going to be 5. So here is our first length. Now, when x equal 2, which is 2 is going to be the second length for the second rectangle. When x equal 2, y is going to be 5 divided by 2. Just keep it 5 divided by 2. Do not convert everything to a decimal until you find the solution. The third length, when x equals 3, y is going to be 5 divided by 3. Keep it 5 divided by 3. When x equals 4, y is going to be 5 divided by 4. 5 divided by 4, x equals 4. When x equals 5, which is the last one, y is going to be 5 divided by 5, and it's going to be 1. So now I have the length for each triangle. For x equal 1, here is the length, equal 5, and the width equal 1. So to find the area, we're just going to add the area for the first triangle, the area for the second one, the area for the third one, and the area for the fourth one. So the area is going to be the area, the length for the first, because we're going to use the same for the triangle, is going to be length times, or let's say width. Now, for the first triangle, the length is 5. The width is 1. So it's going to be 5 times 1 plus. For the second triangle, the length is 5 over 2 times the width is 1. For the third triangle, the length is 5 over 3 times the width is 1. For the fourth one, the third one, the fourth one, the length is 5 over 4. The width is 1. And for the last one, there is no triangle here. The length is 1. The width is 1. It's not going to change anything. So we can keep it 1 times 1. But our area does not include this part, because we have how many triangles? We have just 1, 2, 3, 4. So we don't need 1, 2, 3, 4. That's it. So you don't have to do when x equals 5. Let's check how much is going to be the result for this one. Is going to be 10.417. Now we're going to do the same steps for the second graph. For the second graph, that's the difference. We're going to use the same formula, y equals 5 over x, but the difference is How many triangles do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 triangles. That means we're going to divide each triangle here to 2 triangles and 2 triangles here. That means the width for each triangle is going to be 0.5. And we're going to go back and find the length for the first triangle, the length for the second one, the length for the third one, and keep going until we reach number 5. So keep in your mind, the width is going to be 0.5. We're going to use the same formula, y equals. So now when x equal 1, when x equal 1 is going to be y equal 5 divided by 1 is going to be 5. When x equal 2, not 2. The second point here, be careful. So x equal here, 1.5. That means y is going to be equal 5 divided by 1.5. I'm going to keep it like this. Do not convert it, just keep it like this. The next point, x equal 2. So y is going to be equal 5 divided by 2. The next point, x equal 2.5. So y is going to be 5 divided by 2.5. Next point is going to be x equal 3. That means y is going to be 5 divided by 3. Next point, x equal 3.5. So y is going to be equal 5 divided by 3.5. So now we are 3.5 here. We need 4, 4.5. That's it. We're going to stop here until 4.5 because at 5, there is no triangle, rectangle here. There's no rectangle here. So 3.5, when x equal 4, y is going to be 5 divided by 4. And when x equal 4.5, y is going to be equal 5 divided by 4.5. Now, we already know the width for each triangle is 0.5. So to find the area is going to be, for the first triangle, is going to be the length is 5 times the width is going to be 0.5. So here is the first triangle. For the second one, plus the second length is going to be 5 over 1.5 times the width 0.5. The third one is going to be 5 over 2 times 0.5 plus next one is going to be 5 over 2.5 times 0.5. I'm going to keep going here. Plus next one is going to be 5 over 3 times 0.5 plus next one is going to be 5 over 3.5 times 0.5. If you want to convert this one as a cross, so you're not going to do mistakes. This is the multiplication. A plus, next one is going to be 5 over 4 times 0.5. And the last one is going to be 5 over 4.5 times 0.5. This is the last triangle. And the result is going to be, let's see, 9.145. If you check the difference between the result from the first one, which is 10.417 and 9.145, the difference between the second one is more accurate from the first one. That means when you increase the number of triangles, you're gonna approach the when you increase the number of a triangle, you're gonna approach to the exact area. So, and that's why it's important to study the limits first, and then we're gonna find the area by using the limits, which is going to be the next section. So the next part, let's put the result here. The first one is going to be 10.417, and the next one is going to be 9.145. And you see, this one is more accurate from the first one. That means increase the number of a triangle, you're gonna get approach to the exact area. That's it. Don't worry about that. We're gonna learn each details when we reach section 5.2, how we're gonna find the exact area by using exactly the same steps. That's it for this section.